Hi everyone, welcome to Leetcode daily programming. So let's solve the problem add two numbers. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contain a single digit. Add the two numbers and return the sum as a new linked list. You may assume that the two numbers do not contain any leading zeros except the number 0 itself. So we are given two numbers which are stored in a single linked list and these linked lists are stored in reverse order. The numbers are stored in reverse order. That means the least significant bit will go as a head of the linked list. So let's see examples to have better understanding. So here the head node is having a value of 2, the next node has a value of 4 and the next node has a value of 3. So if you see here it is like 243, but they are stored in reverse order, so the actual value of this linked list is 342. Same way the second linked list has a value of 465, not the other way around. So when we add these two numbers we get 2 plus 5 7, 4 plus 6 10, so 1 will go to next digit as a carry forward, then 4 plus 3 7 plus a carry of 1 8, so we get a value of 708, but the actual value is 807. So similarly in example 2 we have two numbers which are two linked lists which are having 0 values, so result will be 0. As mentioned earlier, if the number is 0 then only there will be a 0, otherwise there won't be any leading 0. In example 3 we have huge numbers, so after adding we get a result of this one. So so how to approach this? Let's look at the constraints below. The number of nodes in each linked list will be in the range 1 to 100, so this will not be very huge list, and the value of each node will be, as expected, it will be between 0 to 9, and it is guaranteed that the list represents a number that does not have any leading zeros. Okay, so how do we approach this problem? So for timing, let's forget that we have linked list. Let's say we have two numbers. For example, the first linked list is 243. The value of this linked list is 342 because they are stored in reverse order. 2 is the least significant bit, so 2 will come here. 342. Second list is 465. So in what we have learned addition in our school, right? So how do we do that addition? Let's see. First we start from least significant bit, so that is 215. So when we add 215 we get 7. Then we go to next digit, so 4 plus 6 10. Then we have a carry of 1. Then 4 plus 3 7 plus a carry of 1 8. 7 plus 1 8. So we get a value of 807. So when we represent this in linked list, it will be 7 0 then 8. So this should be our answer, 708 as a list. 708 should be the answer. So basically we just follow the addition that we have learned in our school. We just add numbers from starting from least significant bit, then we keep storing those values in a new node, create a new linked list, then finally if there is a carry we add that carry to the next node, and so on. Then finally return the head of the new linked list that we have created. So let's look at the source code for both Java and C++. Let's look at the solution for Java first. So we have a variable carry which will keep track of if there is any overflow. If the number is more than 9, it will keep storing the carry. Then let's take, for simplicity of the code, let's take a new dummy node. So I'm creating a head here, list node. So this is like a dummy node. We are going to return the head of next as our result. So we are going to store all the nodes starting from head of next, because this is just to keep the things simple. If we take head as a null and then start creating linked lists, then we need to have multiple if conditions, like if the head is null then create head, if head is not null then add node to the head of next. So those if conditions will be we can save on those few if conditions. So generally if you see, we use a dummy node to avoid those if conditions. Yeah. So then we have to iterate through the both the lists. So as long as L1 is not equal to null and L2 is not equal to null, so one of the lists is not null, then we try to add the numbers. So we take the value. So value will be carry plus, if L1 is not equal to null then take value of L1, if L2 is not equal to null then take value of L2, and add all the three values and finally get a value. So this value can be from 0 to, it can be more than 10 as well. So when it is more than 9, we will have a carry. So first we need to calculate the carry value. So value by 10 will give us the carry which will go to next digit. Then we create a new node. So temp is currently pointing to head, which is a dummy node. We are not going to use that. If you see here, we are going to return finally head of next. So head is a dummy node. So we are creating a new node with the value that we have got. So the value will be value %10. So we take a mod operation just to ignore if the number is more than 9. We take only the remainder. So it will give us 0 to 9. So we will create a new node. We assign it to temp of next. Then we move temp to temp of next. And if L1 is not equal to null, we move list 1 to next node. Again, if L2 is not equal to null, we move L2 to next node. Then so we keep iterating through. If one of the list is not equal to null, we keep iterating, then keep adding, and finally we need to make sure that there can be a carry at the last node. So if we have two 9 digits at the last, we are going to get 18 as a result. So we store 8, but there will be a carry of 1. So that for that carry, we need to create a new node because it will not fit in the current linked list. So if the carry is equal to 1, we create one more node with the carry. Then finally return head of next. So if you see third example here, see we have 999 here. So all the digits are 9. So there will be a so if you see 1, 2, 3, 4, 5, 6, 7. Here we have 7 nodes, whereas here 1, 2, 3, 4, 5, 6, 7, 8 nodes. And the final node will be a carry 1. So to handle this case, we have the additional if condition outside of while loop. So let's submit and check. Yes, so the solution has been accepted. Let's see runtime after looking at C++ solution. So C++ it is again same. So we have carry, then we have temp node, dummy node, and we take temp as address of head. Then we iterate through one of the list is not equal to null. Then take value, calculate new value for the current node, including carry, then value from L1 and value from L2. And then calculate the carry again, value by 10, then value %10 will give us the value of the current node. So create a new node, assign it to temp of next. Then we move the list from L1 to L1 next, L2 to L2 next. Then finally create a new node if there is a carry and return head of next, the same as Java. So let's submit and check the runtime for both Java and C++. So the solution has been accepted. So runtime of 2 milliseconds for Java and a runtime of 32 milliseconds for C++. So if you look at the source code, we are not using any additional we are trying to iterate through both the lists. So if the size of linked list, if the maximum of these two linked lists is n, let's say n is the size of the maximum linked list, then our time complexity will be in the order of n, because we are going to traverse through the whichever is the bigger list, we are going to traverse the entire list. So it will be in the order of n, if n is the maximum length of one of the lists. And when it comes to space, again it will be same O of n. We are using additional space for n nodes. If we say there will be a maximum of n nodes, then it will be O of n. So both time and space complexity are O of in the order of n. So that's it. Thanks for watching.